very last page of your notes, we're going to turn back to this page from time to time. We want to be able to address exponential functions, y equals a to the x, and I'm simply going to pull up my calculator, and I'm going to type in, first I'm going to turn it on, type in y equals 2 to the x. I'm going to look at the table here. I'm going to delete some values, and I'm going to plug in some x values and see what pops up. What is anything to the 0 power? It's 1. And if you plug in 1, 2 to the first power is 2. 2 to the second power is 2 to the third power is 2 to the fourth power, 2 to the fifth power. Yeah, so what's happening to the y values? Tell me something about the y values, anything. Okay, they're doubling every time. Would you agree that they're getting progressively larger very quickly? Exponential functions get larger very, very quickly. Very quickly. And so that gives us an idea of the behavior. The fact is that everything, every exponential function, unless it has a transformation, passes through the point 0, 1. And as you head to the right, just trends upward. But a better question is what happens as it trends to the left? So anybody know what 2 to the negative 1 power is? 2 to the negative 1. 1/2. Yeah, if you type in negative 1, you get 0.5. Negative 2, you get 1/4. Negative 3, you get 1/8. Look at these values. What's happening to these values? They're getting smaller. In fact, what are they kind of getting closer to? 0. Yeah, they're never going to cross over 0, but they're going to get close to 0. And so this side of the graph looks like that. The graph has what we call a horizontal asymptote. The domain is always all real numbers for exponential functions. You can plug in whatever you want. The range in this situation is from 0 to infinity. Do not include the 0. And then finally, the asymptote is going to be y is equal to 0. Are there any questions about the graph? What shape does that make? A line. What shape does that make? See how they all have a 2 and an x? You got a line, got a parabola, got an exponential. They're different. You need to understand that right now, this is what we're dealing with. Okay, I know it's not in your normal way of thinking. You spend most of your time in algebra focusing on those. I get it. Now we're going to a different area. That's not that big of a deal. Suppose that your base value, so right now our base value, we looked at y is equal to 2 to the x. Now we're going to look at y is equal to, say, 1/2 to the x. We're gonna create the base so that the base is between 0 and 1. So it's like a fraction, okay? And I'm going to help you kind of think of why the graph makes the shape that it does. And you don't have to write this down, but see if you can follow along with this. Y is equal to 2 to the x, and then y is equal to 1/2 to the x. Would everybody agree that 1/2 is the same as 2 to the negative 1? So if I take an exponent to an exponent, I get y is equal to 2 to the negative x. So y equals 1/2 to the x is the same as y equals 2 to the negative x. Well, how do those graphs compare to each other? They're just about the same. It's just a flip, and the flip is a horizontal flip because the x is negative. So as we look at the graph and the way that it trends, we would say that it still passes through the point 0, 1, but instead of starting down and finishing up, it starts up and it finishes down like so. Still has that asymptote and everything else. So that's the difference. If you see a number that's less than 1, it's going to have that kind of behavior. Okay, it's going to have that kind of behavior. And then all of a sudden you see, you know, y equals e to the x. And then you start to really panic because you're like, what the heck is e? E is just a number. Like pi. Pi is, you know, 3.14. Well, e is a number that comes up when we talk about exponential growth. For example, so we got a cell phone here. You got a cell phone? Can you flip it up? If I tested your cell phone right now for bacteria, would I find any on it? Yeah, you would. Sure you would. They're super dirty. They're really dirty. You have more bacteria in your cell phone than you do on your toilet seat. I wouldn't encourage you to, you know, like test that, but that's what all the studies show. Right now, you're like, holy cow, I want to wash my cell phone, right? Right? Sure. Yeah, they actually sell cell phone washing like machines. Have you seen these things? Like little boxes. They got certain light and like, yeah, yeah, yeah. Exactly. Super cool, right? So anyway, if we were to model the rate of growth of bacteria on your cell phone, that's the number that would be the base. It represents growth that happens in the natural world. So if you look at that graph, it looks just like the first one. It's just that the base, instead of 2, it's 2.7. The base is bigger than 1. So it looks just like that first graph. And y equals e to the negative x. That's the same thing as y equals 1 over e to the x. It creates that flip, and it looks just like that. Everybody have a basic understanding of these general shapes? Our goal today is to graph these shapes, understand their behavior, and go from there. Okay. So flip all the way to the front of your notes, These are our 4 sections that we're covering. We start with exponential functions. Sketch a graph the following. State the domain, the range, the asymptotes. We're also going to state 1 point on the graph. 4 to the x. 4 is bigger than 1, so it starts down and it finishes up. Anybody remember that special point that it went through? 0, 1. Anybody remember what the domain of this function is? Or can you look at the picture and tell me what the domain is? All real numbers. How about the range? 0 to infinity. I do not include 0. The asymptote is the line it approaches but never touches, which is y equals 0. So, A for the day. How is the next one different? Why? The base is smaller than 1, and so therefore, instead of starting down and finishing up, it starts up and it finishes down. Still goes through that point. We have that horizontal asymptote. We have the domain of all real numbers. We have the range of 0 to infinity. And we have the asymptote of y is equal to 0, and it goes through the point 0, 1. Any questions on that one? Is the next one going to look like the first one or the second one? Why? Excellent. So it'll be like the first one. We could just skip it. How about letter D? Is it going to look more like the first one or the second one? First one. What does the negative do? Is the negative on the outside or inside? Outside, so it's going to create a vertical flip. Very good. So that means that it will be flipped over the line, over the y-axis or x-axis. Instead of going through 0, 1, it's going to go through 0, negative 1. What is the domain? Always all real numbers. How about the range? That's different this time. And the asymptote? Y equals 0. How about the next one? Down 4. So that means the asymptote, instead of being at 0, is going to be down at -4. It used to go through the point 0, 1. So instead of going through 0, 1, what does it go through now? 0, -3. Domain. All real numbers. Range. -4 to infinity. We go from the asymptote on up. You said something. Oh. Can you elaborate on that? Confused on what? Do you see now? Awesome. You try F on your own. This one's definitely more complicated, but one I'd expect you to be able to do. Practice. All right, here we go. Let's check it out. Amen, brother. Okay. This is what the parent function looks like. Why does the parent function look like that? Because you got a 2/3. So the transformation that's going to occur is 2 to the right and 1 up. So I'm going to take this graph. I'm going to move it 2 to the right. I move it 1 up. The 1 up will change the location of the asymptote. So that's what the graph looks like. Domain. All real numbers. Range. 1 to infinity. Logan, it passes through the point. 2, 2. And then we have the asymptote is y is equal to 1. Flip it over. Got these 4, you're done. As I teach you how to do these 4 problems, they are not complicated. Yet on the test, they are some of the most common problems for people to get incorrect. I'm going to try a strategy of creating fear and anxiety in you so you don't get it wrong. So if I sound like I'm yelling at you, it's because I am. Are you ready to get yelled at? When you write an equation for a line, y equals something, mx plus b, if you knew it passed through the point, let's say it passed through the point 3, I don't know, 3, 1, I don't know, 3, 7, we'll say 3, 7. And suppose it has a slope of 2. Would you write the equation like this? Would you write your final answer as 7 equals 2 times 3 plus 1? Would you write that as your final answer? No, you wouldn't. You wouldn't do that. You'd write it as y is equal to 2x plus 1, right? That's what you would do. But when you get to exponential functions, your brain goes to kaput and you write down gibberish. Like you want slope, you want y-intercept. You leave this y and this x like this is important, right? So let me show you what happens when you get to the exponential functions. I want to write an equation for an exponential function. So that means y equals some number a raised to the x power. What do you think we solve for? What do you think we want to know? Like in this problem, we want to know m and we want to know b. What do you think we want to know in this problem? A, that's all we want to know. And it's super easy. This is x and this is y. So you get 25 is equal to a squared. Who could tell me what the heck a is? 5. Way to go, Doyle. So people write their answer like this. A equals 5. And you know what I do? I do this. -1 on the test. Think about it, folks. if you would write an equation for a line like that, what do you think should be the equation for this exponential function if a is 5? That I can give you points for. Here's something else I can't give you points for. 25 is equal to 5 squared. Great. I know that, but that's not an exponential function. Time to take more points off. Now I'm getting really angry. I'm going to take 2. Just because I'm in a bad mood. Can you please not do that on the test? Danny doesn't look convinced. Now he looks convinced. All right. We try the next one. I need y equals a raised to the x power. What is my y value? 2/3. What is my x? -1. What number do you raise to the -1 to get 2/3? What does it mean to take something to -1 power? You flip it. So what number do you flip to get 2/3? 3/2. So a is 3/2. So I write my final answer as y equals 3/2 raised to the x power. That'll get me points. That won't. You try the next one on your own. Notice they all go through 0, 1 because they're exponential functions. So don't use 0 and 1. That won't tell you anything. I got y is equal to 2 to the x. All good? Okay, the last one. 1/10,000 is equal to some number a raised to the 4th power. What number do you raise to the 4th power to get 1/10,000? Okay, let's make it easier. What number do you raise to the 4th power to get 10,000? Oh boy. How many zeros do you have here? 4. What number do you multiply by itself 4 times to get 10,000? 10, right? 10. So what number you would multiply by itself 4 times to get 1/10,000th? 1/10, right? Write your equation. Y is equal to 1/10 raised to the x power. Some people don't like to write it as 1/10, and instead they write y equals 10 to the -x. Those are the same. You could do either one. Can I show you how to figure out that it's 1/10 using your calculator? If you want to solve for a, you need to take the 4th root of both sides, don't you? So just simply take out your calculator, and if that will help you, and go the 4th root, or 1 divided by 10,000, you're going to raise it to the 1/4 power because it's the 4th root. 1/4. Your calculator, fine, it's 1/10 for you. If you want to convert to fraction, math, convert to fraction, you know, all that good stuff. It's amazing. All right, there you go. Exponential functions, introduction.